Alright guys, next section, scatter plots and lines to fit. And I kind of pre-typed my own notes. So today we are going to interpret points on a scatter plot, and we will use lines to fit or off fit to make and evaluate predictions. So going back to bivariate data, two variables that are somehow related. So we talked about this in the previous two sections. And the scatter plot, which I know you have worked with in before, it is a method to organize bivariated data on X and Y plane. So if we look at the scatter plots, we can have three type of scatter plots. We can have a scatter plot that will have a positive correlation, and what happens as X increases, the Y increases, right? So if X is getting bigger, the Y is getting bigger. For the negative correlation, as Y is getting smaller, then X is going to get larger, or I should start with as X because this is independent. So as X is going larger, the Y is getting smaller. And this is scattered, all the points are scattered, so there's no correlation. So let's take a look at this first example. This first example, we have the graph shows the average number of students per computer in Maria's school. Determine whether the graph shows positive correlation, negative correlation, or no correlation. If there's a positive or negative correlation, describe its meaning. Well, I already wrote my answer, but I was able to draw a nice line of fit, and I see that it is a negative correlation. And if I want to interpret this, I will say that as the year increases, the number of students per computer decreases. All right. If we go to the next page, we have a second example, and the second example says that the graph shows the number of mail order prescriptions. Determine whether the graph shows positive correlation, negative correlation, or no correlation. If there's a positive or negative correlation, describe it. So if we think about this for a second, again, I draw the line of fit. And I see that this is a positive correlation, and my explanation is that as the time increases, the number of mail order increases. All right, and the definition of a line of fit, it is an estimated line to represent the data through middle of points. And what we do want to have is we want to have approximately the same number of points on top and below of the line. So if I just quickly look at the previous example, well, this fit pretty well. This is a straight line and it kind of goes through the points. But if I go to my previous one, I want you to see how I graph this, and I have a couple points here above the line, and here I have some below. So it kind of fits in. My printer is not the, well, it's acting up already. So that's something that you want to be looking for when you are drawing the line of fit. And we are going to use the linear functions to model the data. And the steps that we are going to use is, first of all, we are going to make a scatter plot, and we will determine whether there's a relationship. Then we will draw a line that seems to pass close to the most of data points. And then we will use the 2 points on the line of fit to write an equation of a line, and then we will use the line of fit to make our predictions. All right, and I will show you an example. So there's a first example. I already have the notes done. So we have the table shows the world population growing at a rapid rate, and we want to identify the independent and dependent variable, make a scatter plot, and then decide what is the relationship. And then we also want to answer the questions that we have below. So first of all, independent and dependent. The year is always the independent. The time will go by no matter what. So this is my independent and this is my dependent. And I answer the first question. The second thing is I put the points on the graph, and I made the line of the best fit. And I try to make sure that, see, I have two points under and 2 points above. So I answered this question as well. Now the next question asks me to write the slope-intercept form of an equation for the line of fit. And to start this is going to be the very first thing that you need to do, is you need to remember the point slope. What is the point slope form of the equation of a line? So y minus y1 is equal to mx minus x1, where we remember that m represents slope. And then x1 and y1 is going to be a point that we are going to use. So the 2 points that I want to use for writing my equation, I will take this one and this one. And the coordinates of those 2 points are listed right in here. So if you take a look. And the first thing that we need to do is we need to find the slope. So to find the slope, we'll find the change in y values over the change in x values. I use the calculator to do all those calculations. Feel free to do that as well when you are working on your class or on your homework. So the difference between the y values is 5400 and the difference between x values is 154. I will divide those two numbers, or I did divide those two numbers. 35.1 is my slope. Now I decided to use this point as my x1 and y1 to plug in into the point slope equation, and I will get y minus 1000. 35.1 is my slope, which I replaced with the number I got, and then x minus 1850. Now this is asking us about the slope intercept form. Notice this is point slope. Slope intercept form would be y is equal to mx plus b. So what we need to do is we need to clean this equation up. We need to distribute and then move 1000 on the other side, which I did. So if you look at my calculations, 35.1x minus the multiplication, the product of those two numbers is 64,935. Add 1 to this number, and this is going to be our final equation. Now, to make predictions, you will take your equation and notice that your x represents the year. So if we want to figure out the population in 2020, I am plugging in 2020 in place of t. And again, I put everything into the calculator, and my answer is 6,967. Keep in mind that this was in millions, so that would be 6,967 millions. All right, if we go on the next page, this is a problem about baseball. We have the table that shows the average length of minutes of professional baseball games in selected years. And I made the scatter plot. When you make the scatter plot, you should see that there's no correlation. And if there's no correlation, well, this is my explanation for the first part of the question. I cannot draw the line of fit for the scatter plot, and I cannot write the equation. And I cannot make any prediction because there's no correlation between the independent and dependent variable. Make sure you do the practice carefully and let me know if you have any questions.